Guided practice 3. Given this diagram, show that theta equals arctangent 2 over x minus arctangent 1 over x. When you see this diagram, notice that this is a right angle. And also we have arctangent. You got to use SOHCAHTOA. From this diagram, we do know theta equals alpha minus beta. For this triangle OAC, tangent alpha equals 2 over x, and tangent beta equals 1 over x. So alpha equals arctangent 2 over x, and beta equals arctangent 1 over x. Therefore, theta equals arctangent 2 over x minus arctangent 1 over x. Let's go to second one. Hence or otherwise find the exact value of x for which theta is a maximum. Theta is a maximum means d theta dx equals 0 to solve for this x. Or you can use this notation. Theta prime of x equals 0. We will use this notation. Theta prime of x equals arctangent 2 over x minus arctangent 1 over x prime. This formula is given in the formula booklet. From this, we can figure out arctangent u prime equals 1 over 1 plus u squared times u prime. So for this arctangent 2 over x prime equals 1 over 1 plus 2 over x squared times 2 over x prime. This equals 1 over 1 plus 4 over x squared times. This equals 2 times x to the negative first power prime. Use power rule. 2 times negative 1 times x to the negative second power. Simplify. 1 over 1 plus 4 over x squared times negative 2 over x squared. Denominator multiply. Distributive property x squared plus 4. Numerator is negative 2. So equals negative 2 over x squared plus 4. Use the same way we can figure out arctangent 1 over x prime equals 1 over 1 plus 1 over x squared times 1 over x prime 1 over 1 plus 1 over x squared times negative 1 over x squared. denominator multiply. We will get negative 1 over x squared plus 1 minus negative 1 over x squared plus 1. Negative negative is a positive. Negative 2 over x squared plus 4 plus 1 over x squared plus 1. We will put this fraction together. Denominator multiply. X squared plus 4 times x squared plus 1. Negative 2 times x squared plus 1 plus 1 times x squared plus 4 equals denominator x squared plus 4 x squared plus 1. Numerator distributive property negative 2x squared minus 2 plus x squared plus 4. Simplify again. Negative x squared plus 2 over x squared plus 4 times x squared plus 1. Then we need to solve theta prime of x equals 0. Negative x squared plus 2 equals 0. Since this x is the length, it must be greater than 0. X equals square root of 2. This is the exact value. And justify that this value of x gives the maximum value of theta. For this justifying the value of x give the maximum value of theta, either you will use a sign diagram for theta prime of x, or you use theta double prime of x. I will show you both. Theta prime of x equals negative x squared plus 2 over x squared plus 4 times x squared plus 1. There is no vertical asymptote line. We figure out the root is the square root of 2. Then draw this sign diagram, square root of 2. Remember this x cannot be negative number. Let's use 1 as the testing number. We plug 1 into this equation. We got here is a positive, negative. So increasing then decreasing. This is a maximum value. So theta has a maximum at x equals square root of 2. If we want to use the second derivative, we will figure out theta double prime of square root of 2 equals. Go to calculator, click on 1, then go to graph 2. f1 of x equals arctangent 2 divided by x minus arctangent 1 divided by x. Enter. We got this graph. Tab, shift, minus to get this derivative. Variable f1 of x. Enter. We didn't see any graph here. Click on tab, shift minus, dx, ddx of variable f2 of x, enter. We didn't see any graph here. Let's add one more page. Calculator, variable f3 of square root of 2, enter. Calculation cannot be completed. This time we need to change this f2 of x into the function theta prime of x into this f2 of x. f2 of x equals control divide negative x squared plus 2 over parentheses x squared plus 4 times x squared plus 1. Then enter. This time we got this graph. Then go to 1.2. Variables, go to f3 of square root of 2. Enter. Negative 0.157. Just remember, if you put derivative of f1 of x and you couldn't see the graph, you need to put the real derivative function into f2 of x. So theta double prime of square root of 2 equals negative 0.157 less than 0, concave down. So theta has a maximum at x equals square root of 2. Question 3. Find the maximum value of theta. Since we already figured out theta has a maximum value when x equals square root of 2, we just need to substitute the square root of 2 into this function. Theta of square root of 2 equals, let's go to calculator. We already put f1 of x is the function for theta. So f1 of square root of 2, enter. 0.340, 0.340. This is the maximum value of theta.